This is a video on partial fractions. The question is to integrate 3x squared plus 3x plus 8 divided by x times the quantity of x squared plus 4. What makes this integral difficult is that x squared plus 4 doesn't factor. But instead what I can do is I can write the partial fraction decomposition. I have my a over x because of this x factor, and then the x squared plus 4 factor is going to give me a bx plus c. Whenever I have a quadratic that doesn't factor, I put a bx plus c up in the numerator. So now I put this under a common denominator, and I have ax squared plus 4, and I'm going to have a bx plus c times x, and I equate that to the numerator on the left-hand side. So a times x squared plus 4 plus bx plus c times x is equal to 3x squared plus 3x plus 8. Now if I let x equal 0, 0 squared plus 4 is 4, so I get 4a. This term goes away, and 0 plus 8 is just 8, and I get 4a equals 8 divided by 4, and that gives me a is equal to 2. So now if I plug a equals 2 in here, I get 2 times x squared plus 2 times 4, or in other words, 2x squared plus 8, and now multiply the x through, and I get bx squared plus cx equals the right-hand side. Now let's combine like terms by moving the 2x squared and the 8 over to the right. 3x squared minus 2x squared is x squared, and the 8's cancel, and I'm left with bx squared plus cx is equal to the x squared plus 3x. Now I could equate coefficients. The x squared coefficient is 1 on the right-hand side, so that means b is 1. The x coefficient is 3 on the right-hand side, so that means c equals 3. Now I could plug these numbers into the original integral with the partial fraction decomposition. A is 2, so that's 2 over x. And then I get 1 times x plus 3 over x squared plus 4. I put that into the integral, and I get 2 times the integral of 1 over x dx plus the integral of x plus 3 over x squared plus 4 dx. This first integral is easy. That's just natural log of the absolute value of x. For the second integral, what I can do is I can break it up into two integrals. I can write this as x over x squared plus 4, and I can write 3 over x squared plus 4. Now let's work out these integrals. For the first integral, I can use a u substitution, because if u is x squared plus 4, then du equals 2x dx, and there's my x dx, so I just have to pull a 1/2 du outside. For the second integral, I can divide by 4, or pull out a 1/4, and what I get is a 3/4. The 4 divided by 4 becomes a 1, and x squared divided by 4 becomes x over 2 quantity squared. The first integral is just a natural log of u, or natural log of x squared plus 4. And the second integral, I can let u equal x over 2, then du equals 1/2 dx. And I could realize this as 3 over 2, basically 1/2, if du is 1/2 dx, then 2 du is dx, and 2 times a 4th is 1/2, and that's why I have a 2 here instead of a 4. Then I have a 1 plus u squared du. So now this integral here is an arctangent. So what I get finally is the natural log of x plus 1/2 the natural log of x squared plus 4 plus 3/2 the arctangent of u, and u is x squared over 2, plus c. And I'm done with the problem.